All right, these notes are helping us learn about a couple transformations that you have probably not worked with before. And so we have seen, if you look at this first one, we've seen problems where you have the number in front, like 2 multiplied in front, and you'd be like, oh yeah, that's a vertical stretch. But here we don't have that. And so what we're going to do is we're going to kind of reason our way through this. And you have this packet that has these pictures on it, and the packet is great because it gives you these examples and it kind of walks through. But I'm going to go ahead and on a separate sheet of paper, I'm going to write some tables so that if you need to crunch the numbers, you can kind of see how it all works. So we're going to call this original graph f of x. And we're going to choose some important points that are on f of x. So we've got -4, 1, -2, 4, 4, 4, and 6, -4. So we've got those 4 points. So I'm going to go ahead and write those down. All right. Now, if you look here, we have 2 transformations. We've got the negative in the front, and as you guys know, that reflects it over the x-axis. And we have this 2 with the x. So if you think about mathematically what this is truly saying, it's saying in the original function, whatever your x's were, you should be multiplying them by 2. So if we think through this, and what we're going to do is we're going to go ahead and we're going to do this transformation, we're going to do it in 2 parts. So the first part, we're going to ignore the flip over the x-axis for now because you guys are comfortable with that. We're going to go ahead and work with this part where we're just adjusting that inside part of the function. So if you think about this, if I was to take an x and multiply it by 2 and my answer ended up being -4, like that's the x that I truly did plug in, then that means that I must have plugged in a -2, right? Because 2 times -2 is what would have given me the 4, and the 4 is what really evaluated and produced a 1. For this one, the number that must have been there, it must have been a -1, because then when I did 2 times -1, that forced us to be a -2. Here, this one must have been a 2, and this one must have been a 3. So basically what this does, if you can picture it in your head, is it used to go out to -4, now it only goes out to -2. And it used to go all the way to the right to 6, and now it only goes to 3. So what we notice here is that when you have a whole number, or a number that's greater than 1 in front of the x, that actually makes a compression instead of a stretch. And it does it to the left and right, so this is a horizontal compression. And again, the reason that we know that is because the number, we're not changing what you get after you plug in the x, we're changing the x that we're actually plugging in. And so that's how I know that I'm changing the x value. So now my y value should stay the same, 1, 4, 4, -4. And if you were to compare this with the graph that they put on your paper, these points would all match up. So -2, 1, -1, 4, 2, 4, and 3, -4. And so the little note that they made here is multiply all the x values by 1/2. So basically, we're looking at this and we're seeing a whole number 2, and so that means it's a horizontal compression, so you'd be taking half of each thing. So when you look at this, you're going to take the reciprocal. So if we had a graph, for instance, that said f of 1/3 of x, then you would actually be having a horizontal stretch, and you would want to multiply all your x values by 3. Okay. Next, what we would do is we're going to actually do that reflect over the x-axis. So when you take something and it's above the x-axis and then you flip it so it's below the x-axis, you're taking a point and you're moving it from up to down. And up to down would be a change in your y-coordinates. So all these x values are going to stay exactly the same. They're not being adjusted here. But when I reflect them over the y or the x-axis, what's going to happen is all these y's are going to change their signs. And if you compare this to the results, then you can see that those points are in fact the same. So if you are someone who is visual, you can do it visually like they did and kind of do it one step at a time. If you're not visual, if you need these numbers here, then you can go ahead and write them in chart form. It's up to you. So I guess reflect over x-axis here. Okay. All right, we're going to do another one, example 4. So you don't have to ignore all the other examples. I just didn't think I needed a video going over every single one. So this one actually includes a few transformations. If you look in the front, we have a vertical compression of 1/2, so it's going to be half as tall in the very end. And then we have a little negative sign inside, which we'll talk about in a second, and then we have a 2 inside. So we actually have 3 transformations that are happening here. So when we look at this one, again, we're just going to choose a couple points to work with for the original. So I'm going to use this point, and this point, and this point, so that I know which points that I can do the transformations on. So I've got -4, 0, -2, 4, and 0, 0. And these transformations, actually, they can be done in any order. And so I'm going to go ahead and do the order they did on the sheet so that your notes match up with the example. But just know that you don't necessarily have to do these in the same order that I'm doing them right now. So the first thing they did is they said that they multiplied the x values by 1/2. So if they're multiplying the x values by 1/2, that means they're taking care of this 2x, right? So we're saying the x originally, I'm going to ignore the negative for now, the x originally was a specific value, and so if they're multiplying an x by 2 to get that original value, then the x that they were multiplying must have been a -2. And I guess I could up here put f of 2x. So this is what we're dealing with right now. So we're just talking about this, and again it's a 2, so it's a horizontal compression. Okay, so on this one, if it multiplied by 2 to get to -2, then the number must have been -1, and then 0. So again, from here we just multiply by half, multiply by half, multiply by half. And then the y values would have stayed the same. All right. Next, on this example, they went ahead and they multiplied the y values by half. So what they're doing here is they're taking care of that vertical compression. So this was a horizontal compression. And now they're taking care of the vertical compression, so they've got 1/2 now that we're adding in there. So if we're compressing it vertically, that means that all the y values are going to be half of what they originally were. So my x values are staying exactly the same, and I'm cutting my y values in half because my graph is going to be compressed, half as tall. Okay. And then very last thing, they're going to take care of that negative sign. So if you think about it, if you're taking all of your x's and you needed them to be the opposite sign, what happens if you take an x that was negative and you force it to be positive? What you're doing is you're flipping it over to the over the y-axis. So that's what we're going to do. We're going to flip all of them. That means we're changing the sign for all the x's. So +2, +1, 0 stays the same. And we have not changed the y values at all, so we're going to keep those the way that they were. So this was vertical compression. And then this was reflect over the y-axis. Okay. So next in the packet, there's a couple practice problems. You can do those. The answers are at the bottom, which is kind of nice. And then we're going to flip to the page number at the bottom says 106. We're going to look at this example because it's more complicated. So this has, it has the vertical stretch or compression, the horizontal stretch or compression, and it has a left or right movement. It's got a lot of stuff going on. And so I wanted to go through this one so that we could see what happens when you have all of that at once. Okay, so I'm going to go ahead and write down actually I'm going to just go ahead and write the original function to start with, because it has to be adjusted a little bit before we can work with it. Okay, so go ahead and look at this box up here. It says if x has a coefficient attached to it, that coefficient must be factored out of the brackets before proceeding. So if we look here, there's a 1/2 in front of the x, so we have to take out that 1/2. So I'm going to ignore this part. I'm going to factor out 1/2, so that's 1/2 times x. And then I have to think 1/2 times the number equals 1, so the number that it must have been was 2. So 1/2 times 2. So that's all the stuff that's happening inside the function. I'm going to go ahead and, since I already used parentheses, I'll put brackets around that. And then I've got the f and the -2 and the y equals. So if we consider all of our transformations here, we've got a reflection over the x-axis, we have a vertical stretch of 2, and then in here, this is a 1/2, so it means it's a horizontal stretch, because we're going to do the opposite, right? When we had a 2 in front, we were taking half of the number. So now that we have a 1/2 in front, we're going to be doubling the numbers. And then here, we go left 2. So, and again, it's opposite of what you would think. So anything that happens inside is kind of the opposite of what you would think. So if you guys, when you do this, and we were doing, one transformation at a time, it kind of goes along with order of operations, actually. So PEMDAS. We're going to ignore this part because we don't need that. But when you're doing these transformations, as long as you do the transformations that deal with multiplying and dividing first, and then do your addition and subtraction second, you'll do it correctly. So the negative and the 2 and the 1/2, those all require that you're multiplying your x or your y coordinate by a number. And then this one over here, the left or right movement, and if you had an up or down movement, those would be requiring that you would add that number or subtract that number from your x or your y coordinate. So it doesn't matter which of these you do first, so long as they all happen before the ones you add or subtract. And that's because that's how order of operations work. So again, I'm going to follow what they did in the packet so that you're not confused if you compare your notes, but just know that you don't have to do it in the same order I do it, so long as you take care of these 3 things first, and then the 2 has to be the last thing that we do. So first thing, I'm going to go ahead and write f of x, and I'm going to choose points for this graph. So I've got -1, -2, and I've got -1/2, -2. Sorry, it's kind of, there we go. And I have +1/2, +1. And I've got 1, -1/2. So that's the original. Okay. Now, the transformation they did next is they dealt with that vertical stretch. So we're going to go ahead and do that. So dealing with the vertical stretch means that I'm going to take my y coordinate and multiply it by 2. So -4, -4, 2, -3. So I've stretched it vertically. Next, they are dealing with the flip, or the reflection over the x-axis, so we can go ahead and add that. If you want to do the 2 and the negative at the same time, you definitely could. So flip it over the x-axis and get 4. Flip it over the x-axis, get 4. Get -2, get +3. Okay. The next thing that they deal with in the packet is they take the x values and now they're horizontally stretching them. So if I'm taking the x values, actually I'll go ahead and write this up here. -2 f of 1/2 x. So we're taking our x values and we're multiplying all of them by 2. So -2, 4, -1, 4, 1, -2, 2, 3. And then last, what we're going to do is shift left 2. That was the very last transformation that we had. Bracket. So if we're going left 2, we're going to be taking the x coordinate and subtracting 2 from it. And then if you compare, these points would all match up with that final graph. So again, just to reiterate, you are more than welcome to do it visually if you want to follow along with what the packet did, or you can do it kind of algebraically by adding your numbers there.